Welcome to Catalyst Made Web, where we ignite understanding and make learning easier. In our today's class, we'll be looking at regression analysis under statistics. Regression analysis, it is a statistical method that allows us to study the relationship between two or more variables. It allows us to know what type of relationship that occur or that happens between two or more variables. Types of regression analysis. There are two major types of regression analysis. There is simple linear regression and multiple linear regression. Simple linear regression is a type of regression analysis that allows us to study the relationship between two variables, independent variable and independent variables. Whereby the multiple linear regression is a type of regression analysis that allows us to study the relationship between more than two variables. We might be having more than two independent variables with one dependent variable. What are these dependent variables? The dependent variable are the variable that depends upon another variable, whereby the independent variable, they are stand on their own, they are independent of any other variable. For the simple linear, we'll start with simple linear regression. I will say that the simple linear regression is a type of regression that allows us to study the relationship between two given variables, the dependent variable and the independent variables. And the relationship is always linear, which can be represented by a linear equation as y equals to beta naught plus beta 1x. This is a simple linear regression equation, or the model fit regression, that we can be used to find the relationship between the two given variables. Definition of this equation is that y is our dependent variable, x is our independent variable. Independent variable, it is also called the predictor, where y is also called the outcome or the result. Beta naught is our intercept, while beta 1 is the slope. Now, how can you interpret this linear equation model? Our beta naught here, the value of the beta naught is the value of y if x is 0, while beta naught, which is our slope, tell us the value of y, whether it's increasing or decreasing as x is increasing. If your slope is positive, it means as x is increasing, the y will be increasing. While if your slope is negative, it means as x is increasing, the value of y will be decreasing. How do we get to calculate our intercept and the slope? Our slope can be calculated using the formula n multiplied by summation of x, y, minus summation of x multiplied by summation of y, divided by n summation of x squared minus summation of x all squared. Our n here is the total number of the data given, whereby our intercept can be calculated by two different methods. Anyone you use will be having the same answer. You can calculate it using beta naught equals to y bar, that is the mean of the dependent variable, minus beta 1 x bar, that is the mean of our independent variable. Or you can also calculate your beta naught using the formula summation of y minus beta 1 summation of x divided by n. Any of these methods that you use will give you the same answer while calculating intercept. So this is the formula you can use to calculate the simple linear regression model. Let's check this example out. The question said the following data shows the relationship between study hours x and test score y. From there we know that our study hour is our independent variable, while by the test score is our dependent variable. They give us this table here, our x and our y. Then I said we should find the equation of they say we should find the equation of the regression line of y and x. Second question said estimate the test score when a student studies for 7 hours. Third question, state whether the relationship between x and y is positive or negative and give your reason. To the first question, they said that you find the equation of the regression. We said that this is a simple linear regression because we are having only two variables, one dependent and one independent variable. Now, the equation that represents a simple linear regression is equals to beta naught plus beta 1x. Now we want to solve for beta naught and we'll solve for beta 1. After solving for beta naught and beta 1, you substitute your answers in this equation. That will be the equation of the regression line of y and x. Now we should know that this is the formula of our beta naught and this is the formula of beta 1. In the formula, we have to make a table. The table that will contain the summation of xy, the table that will contain x squared as well, and the table that will contain x all squared. Now in our table, we'll be having x, we'll be having y. As given from the question, we'll be having our x, y, and x squared in our table. Now from the question, our x are 2, 4, 6, 8, and 10, whereby our y are 50, 55, 65, 70, and 80. Now for our xy, we multiply our x with y. We multiply 2 by 50 to give us 100. 4 by 55 will give us, press the calculator, 4 multiplied by 55 will give us 220. 6 multiplied by 65 will give us 390. 8 multiplied by 70 will give us 560. And 10 multiplied by 80 will give us 800. Now we'll now go and look for our x squared again. All these values of x, we'll square them. 2 square will give us 4. 4 square will give us 16. 6 square will give us 36. 8 square will give us 64. And 10 square will give us 100. Now, we've gotten our xy, we've gotten our x squared. Then we need all their summations. Summation means you add all of them together. Summation add all the x together, it will give us 30. Summation of y, add all the y together, it will give us 320. Summation of xy, add all the xy together, it will give us 2070. Summation of x squared, it will give us 220. And again, we also need our x squared, summation of x all squared. This one, summation of x all squared is the summation of x squared, and our summation of x is 30. So our summation of x all square will be equal to 30 square, which will give us 900. So what next is for us is just to go and insert everything here in the formula. Then for our beta 1, we are using this formula. Our n is 5 multiplied by summation of xy is 2070 multiplied by summation of x. Summation of x is 30 times summation of y, 320. Everything divided by our n, which is 5, times summation of x squared. Summation of x squared give us 220 minus summation of x all square, which is 900. So from here, we'll be having 5 times 2070.
10350.
10350 minus 30 times 320.
9600.
9600. All divided by 5 times 220.
1100.
1100 minus 900. So this one will give us, our numerator will give us
750.
750 divided by 1100 minus 900.
200.
200. So at last, 750 divided by 200 will give us 3.75. Therefore, our beta 1 is 3.75. We've calculated beta 1. Now we will now calculate beta naught using this formula. We know that this y bar is the same thing as the mean, and mean is calculated by the summation of y divided by n. So for us to calculate our y, we need y bar for us to calculate our beta naught. So our y bar will be equal to, say, is the summation of y divided by n, and the y bar is summation of y divided by n, and our x bar is the summation of x divided by n. Our summation of y is 320 divided by n, which is 5. Summation of x is 30 divided by 5. So our y bar will give us 320 divided by 5. So 320 divided by 5, it will give us 64. And 30 divided by 5 will give us 6. So we can now use this one and solve for our beta naught. Therefore, our beta naught, we say y bar, and our y bar is 64 minus beta 1. That is the value of the beta 1 we've already calculated, which is 3.75 multiplied by our x bar. The x bar is 6. So we'll be having 64 minus 3.75 times 6.
2.5.
2.5, which will now give us 64 minus 2.5.
41.5.
41.5. 41.5. So we've calculated the value of our beta 1, and we've calculated the value of our beta naught. What next is for us to come and insert it in this regression line of y and x. So for us to get our regression line of y and x, we will substitute the beta naught is calculated and the beta 1 that is already calculated. So in that case, our y will now be equals to, the beta naught is 41.5. 41.5 plus our beta 1, which is 3.75x. So this is the regression line of y and x. We solved a part of the question. So the second part of the question said that estimate the test score when a student studies for 7 hours. As you can see from the question, they already tell us our study hours is x. So here, and they say study for 7 hours. In this case now, our x have turned to 7. So our x is now equals to 7. Now we will input this x in the position of the x of this linear regression line that we've already find. So in that case, our y will now be equals to 41.5 plus 3.75 times x, which is now 7. So we're having 41.5 plus 3.75 times 7. Give us
26.25.
26.25. So 41.5 plus 26.25, it will give us
67.75.
67.75. So This is the value of, this is the test score when the student study for 7 hours. They can even say that study for 8 hours. Any hour they mention here will be the value of the x that you substitute with. The next question says that state whether the relationship between x and y is positive or negative. How would you know whether the relationship is positive or negative? You will come here and look at the value of your slope. If your slope is positive, the relationship is positive. And it means that as your x is increasing, your y will be increasing. And if your slope is negative, the relationship is negative. And it means that as your x is increasing, your y will be decreasing. Now, looking at our slope is positive. So the relationship between x and y is positive, because as x is increasing, our y will be increasing as well. Additionally, you can also interpret this result. 41, it is telling you that 41.5 will be the value of y if your x is 0. And also, if a student study for an additional hour, the test score will increase by 3.75. So, our next video will be on multiple linear regression. Kindly subscribe, comment, like, share, and turn on your notification bell so that whenever I release a new video, you will get notified.